Hey guys, we are starting our math daily review number 28. You're going to work on this daily math review for the rest of your at-home learning calendar. So for the last 4 days, this is what I want you to work on for math each day, and then I will post a YouTube video solving all the problems with you. I know a lot of crazy things have been going on in the news, and we're not really sure where things are going to go after our at-home learning calendar ends, so just be patient with us. We will get to you and we will continue learning until the end of the school year, okay? So just stay safe and healthy, and just know I'm here. You can email me, you can message me on Dojo. I shared my phone number if you and your family want to FaceTime me. I just want you to know that I love you and that I'm thinking about you. And I know this is a difficult time for everyone, and it's a difficult time for me as well, because being in the classroom and seeing you is truly the best part of my day. So let's start with number 1. It says, what are the prime factors for the number 30? So I need to know what the word prime means, and I need to know what the word factor means. So factors are numbers that multiply together to get a product. In this problem, our product is going to be 30. So I need to think about numbers, which are factors, that multiply together to get 30. I'm going to list all of my factors, and then I'm going to look for the ones that are prime. So let's just list the ones that we know first. So 1 times 30, 2 times 15, 3 times 10, 4, let's see, 4 would not work. 4 times 6 is 24, and 4 times 8 is 32. 5 would work though. 5 times 6 equals 30. 7 won't work. 7 times 4 is 28, and 7 times 5 is 35. 8 won't work because 8 times 4, 9 times 3 is 27, but 9 times 4 is 36. So here are all the factors that I can find that make 30, and then we are going to circle the ones that are prime. Remember, a prime number is a number that can only be made with 1 times itself. Oop, what am I doing? 1 times itself, or 1 times me. So I know 1 is neither. Prime is obviously composite, because look at all these factors. 2 can only be made with 2 times 1. 15 is composite. It can be made with 1 times 15 and 3 times 5. 3 is prime because it can only be made with 1 times 3. 10 is composite. It can be made with 1 times 10, 2 times 5. 5 is prime because it can only be made with 1 times 5. It has no other factors. And then 6 is composite because it can be made with 1 times 6 and 2 times 3. So the 3 prime factors for 30 are 2 and 3 and 5. Okay, oops. My 5 is looking a little crazy. All right. Hope that was a good review of prime numbers and factors for you. All right, we're going to look at number 2. Number 2 is asking us to find the rule for the pattern. So we kind of ended our instruction on patterns when we were using tables, where we had an input on one side and then a number comes out on the other side, and we had to find the pattern. This is asking for a rule, but we're going to look for the pattern. Same thing. So I know that if 3 is going in and 9 is coming out, and 6 is going in and 18 is coming out, and 9 is going in and 27 is coming out, this is an increasing pattern. And we talked about that in our last session that we had together in class about increasing patterns or a decreasing pattern. So this means that the rule is either going to have to do something with addition or multiplication. So let's say that you were looking at addition at first. You know 6 plus 3 is 9. But if that rule works with this input-output table, it has to work for this one and the next one. So let's try that rule, plus 6. So if I put that rule in the box here and I put in the input, I put in 6 and I add 6, I would get 12, not 18. And if I added 6 to 9 here, I would get 15, not 27. So I'm thinking that the addition pattern would not fit. So can you think of a number times 3 that would get you 9? If you thought of 3, you're right. 3 times 3 is 9. So let's check that rule here. Let's try 6 times 3. If you add 6 3 times, you should get 18. So far it's working. And then 9 times 3. I get 27. So the rule is multiplying by 3. I hope you made sure that you checked your rule in each function table and then didn't just go with your first instinct, okay? All right. Let's look at number 3. Number 3 is a word problem. I'm going to get my calculator up over here just in case we can use it. Okay. It says, Sue purchased 3 bags of candy and she wants to share them with 13 of her friends. If each bag contains 130 pieces of candy, how many pieces of candy will be left over? So there's a lot of information in this problem. She has 3 bags, and each bag has 130 pieces in it. I think that's where we should start. I've got to figure out how many pieces of candy she has before I can share them with friends. Okay, does that make sense? All right, so let's say I have 130 pieces in one bag and I have 3 bags in total. Okay, 3 times 0 is 0, 3 times 3 is 9, and 3 times 1 is 3. So I have 390 pieces of candy if I was Sue, okay? Now she says she's going to share them with 13 of her friends. I am going to assume in this word problem that she is not including herself. I would hope that the word problem would clarify and say 13 of her friends, including herself or plus herself. I'm assuming that this 13 is just who she's going to share with. So if that's the case, let's just type it in the calculator. Let's say we have 390 pieces of candy. My calculator's going to work for me this morning. 390 pieces of candy. And she divides them with 13 friends. Do you see what I got? Ooh, I got a number that does not have a decimal, which tells me that there isn't a remainder here. So let me do that one more time. 390 divided by 13 people gives me 30 pieces each to each friend. I don't see a remainder. I'm assuming right now that there will not be a leftover, but I'm going to double check my division over here on paper. So since you're doing at-home learning, remember I am totally okay if you do your multiples of 13 using your calculator down the side. So 13 times 1 is obviously 13. 13 times 2 is 26. And then 13 times 3 is 39. I'm going to stop right there because 13 can't go into 3, but it can go into 39. 3 times. And I'm going to bring down my 0. Now, can 13 go into 0? The answer is no, so you need to put a 0 up here for. No way. So, looking at our remainder, were there any left over? You should say no. There were 0 pieces left over. And when we looked at the calculator originally, each person got an even number of candy, and we didn't have a decimal back here that symbolized a remainder or a leftover of some sort. So we can go ahead and say that Sue will not have any candy left over. Okay. All right, let's look at this elapsed time question. It says, Sally left her house at the time shown on the clock. She was gone for 9 hours and 22 minutes. What time did she return? I love this problem because I am so glad it has a clock on here. this is a skill for you to know, is reading one of these analog clocks. And I know that you guys all have cell phones and tablets and everything really tells you the digital time now, but a lot of watches have this analog clock still on them. So it is an important skill to have. So let's read the clock first. We cannot solve this problem if we don't see what time it is. So I notice that the hour hand is on 11 and the minute hand is on the 1. So I know my hour is 11, and then if you count the minute marks, you will see that it is 5 minutes past 11. Okay. It says that she left her house at that time on the clock, and we need to figure out what time she's going to return. So I'm still expecting you to set up your number line. Just making sure I have some space. So she leaves her house at the time shown on the clock, and we want to know what time she's going to return. So this time we are finding an end time on our number line. And if we go back to our problem, it does give us the elapsed time for 9 hours and 22 minutes. So I'm going to write that up here. So that tells me I'm going to need to jump 9 hours and 22 minutes in order to find the end time. I'm also noticing in this problem that there is no AM or PM signified here in the problem. So we don't really need to worry about, is it the morning or is it the afternoon? Okay. All right, here we go. So 11:05. I'm actually going to start with 1 hour so that I can get to 12:05. Notice I crossed out how much time I had jumped so far. And the reason I did that is because for me, getting to noon or midnight, depending on what time of day it is a comfortable spot for me to jump. It's a nice benchmark, the middle of the day, and then I can jump my 8 hours. So 12, and then you have 1:05, 2:05, 3, 4, 5, 6, 7, 8:05. So my hours are done. So do you see why Ms. Connolly did that? A very comfortable jump for me, and I could chunk my time appropriately. Remember, if you are not comfortable jumping 8 hours, you could honestly jump 1 hour at a time and be totally fine. All right. So let's address the minutes. 22 minutes, and I have 5 here. I'm going to go ahead, and I'm going to do a 22-minute jump, and I want you to see why I'm doing that. So let's say it is 8:05, and I'm going to add 22 minutes to the clock. 22 plus 5 is 27, and it's still 8. So I know that she will return at 8:27. Do you see how I comfortably did a 22-minute jump, but I showed my work here in the minutes? If you do not feel comfortable doing 22 minutes, again, do what is most comfortable for you. When I first looked at it, I thought about maybe jumping 5 minutes to get to 8:10 and then chunking it a little bit more after that. I'm totally okay with whatever you choose to do as long as you get 8:27, and it looks like 8:27 is an answer choice. So, yay for me, I got the right answer. All right, let's do this last question for today. Oh, it's so good to see you, decimals. I've missed you. So number 5 says, put these in order from greatest to least. That is really important. We are often used to doing things least to greatest. This one just asks us to do greatest to least. All right, what I'm going to do is I am going to put all of my decimals on top of each other. I'm going to stack them by lining up the decimal point. Okay, I want you to notice what I'm doing. I've lined up the place value, ones place, tenths place, hundredths, and then the thousandths. You'll notice that 35 hundredths and 36 hundredths do not have a digit in the thousandths place. It's empty. If you want, remember 0 is your placeholder. So you can fill in that spot with a 0 and you don't change the value of the decimal. For me, I like to fill in the empty spots with zeros because it makes it easier for me to compare or order. So I'm going to start with, let's look for the greatest, and then we'll work our way down to the least. So I'm going to look column by column. They all have a 0 in the ones place. Let's go to the tenths place. They all have a 3 in the tenths place. Let's go to the hundredths place. Remember, I'm looking for the greatest valued digit. If I'm looking at the hundredths place, I have 2 digits that have a 6. The other 2 have a 5 and a 4. So I'm going to look at the 6. If you have 2 digits that are the same, you need to compare the next place value. So these 2 digits have a 6 in the hundredths place, so I'm going to go over to the thousandths. This one has a 1, this one is a 0. I know 361 is larger than 360. So on my number line over here, I'm going to go ahead and put 361 on the greatest, and then I'm going to go ahead and put 360 thousandths right under it. All right. So I'm done comparing those 2 numbers. Now I'm going to use that same strategy with the last 2. So again, looking at the whole number, neither of them have anything in the whole number. If I go to the tenths place, they both have a 3. So I'm going to head on over to the hundredths place. One has a 5, one has a 4. What's larger, 5 or 4? 5 is larger. So I know right away on my number line, I can put 350 thousandths right under 360 thousandths, and I can put 345 thousandths right under 350. Okay? So if I'm transferring that over to my paper, I'm going to put it on the paper like I do on my scrap paper. So this one's good, and this one's good. And then now when I rewrote my numbers, notice I didn't put the 0 in that I used here to order. It's up to you, whatever you feel most comfortable with. And that is Monday's daily math review for number 28. I am so excited to start the week off on this one with you. I can't wait to see you tomorrow. I love you so much.